All right, so here we go with the first part of 2.6, 2.6a. The first question here is what's a 50-50 shot, and it's theorem, right? So it's a theorem. It's a statement you can prove. Remember, a postulate is a statement that we assume to be true, but we can't actually prove it. So what we're doing here is we're coming up sort of with theorems, things that we can prove. Right now, this one is just about sort of justifying. So we're just trying to justify each of the steps. Okay, for this first one, it says write a justification for each step, given that the measure of angle A is 60 degrees, and the measure of B is 2 times the measure of A. Okay, well, that right there is just the given information, so that's not so bad. The next thing that's happening is it looks like we are taking this equation here, and I'm replacing the measure of angle A with 60 because it's here. So I'm just substituting. So I'm replacing 60 degrees with the measure of angle A, which are both two things that are from the first step. Substitution. And these are equations, so property of equality. The measure of angle B is 120. That looks like just multiplication. You can write multiplication if you want to be specific. I would just stick with probably simplify. We can just use those for any sort of math that we're simplifying. And you notice it's not multiplication property of equality. It would be multiplication. That's kind of what we're doing, simply because we're just multiplying 2 times 60. For it to be a property of equality, we need to be doing it to both sides. All right, so then we go here, and it looks like what we're doing is because angle B is equal to 120, what we're doing is we're taking this equation here, and I'm adding to angle A, I'm adding measure of angle B, and to 60, I'm adding 120, right? So I'm adding 120 and angle B, but those are the same thing. So basically what I did is add the same thing to both sides, which I can do in an equation because of the addition property of equality. So the previous steps were kind of just clarifying that B, measure of angle B and 120 degrees were the same thing, which allows me to add the same thing to both sides. Finally, again, we still simplify. We're adding in this case, again, not addition property of equality, because we're just adding those two numbers together to get that. And finally, we're concluding that A and B are supplementary, which is what we're trying to do. Simply because if A and B are supplementary, that means they add to 180. So if they add to 180, they're supplementary. That's just the definition of, oops, I don't know why I put a period there, of supplementary angles. Perfect. So far, so great. All right, write a justification for each step. Okay, so it does say it's given that that it bisects this line BX, this ray BX bisects ABC, and that XBC equals 45 degrees. Well, so far that bisects it. That's a given. Well, what do we know about when a segment bisects an angle? Well, we get two congruent angles, right? That's what bisector means. So right here, it's telling me that because we know that it bisects, now the next step is this is congruent to this. Angle ABX and angle XBC are congruent. Well, that's just the definition of an angle bisector. Sorry, my angles are a little bit. Definition of angle bisector. All right. And then now that we know that if they're congruent, we know that their measures are equal, because that's just the definition of what congruent. That's what congruent means. If you ever again find yourself sort of thinking, oh well, like how do we know the measures are the same if they're congruent? That's just what congruent means. Well, then that's the definition of congruent angles. And then we have 4. So XBC is 45. That actually is given. It's not all givens are all up top. We did use a given and then work with it, but this one was just up top. And in this case, what we basically did is replace XBC here with ABX here because it's equal to XBC, right? So because those are the same, I just sort of replaced it. Replacing is substitution. So substitution, property of equality. And then we have the measure of angle ABX plus the measure of angle XBC equals the measure of angle ABC. Well, that's saying this angle, it's sort of unrelated to the previous things, but it's basically telling us that this angle ABX and this angle XBC are add up to the larger angle ABC. That's the angle addition postulate, right? When we have two adjacent angles, two adjacent angles that add to a larger angle. And then all we're doing here is replacing ABX and XBC with 45 because we know that there are 45 from previous steps. So I'm just doing substitution. And if you want to be sort of more clear with these as you go, we can also say, well, this was substitution and it was based on steps 3 and steps 4. This is substitution based on steps 4, 5, and 6, because we're substituting 4 into 6 and 5 into 6 all at once. Finally, we're just simplifying, right? We're just adding the two 45s together. And now that I know that 45 and 45 gives me this 90, and that 90 equals the measure of angle ABC, it's proving that angle ABC is a right angle because, again, a right angle means that its measure is 90. So if its measure is 90, it's a right angle. That's just what that means. So it's the definition of a right angle. All right, killing it, doing great. In this case, find the measure of each angle. So in this case, we hopefully see that these are a linear pair. Angle 1 and this 48-degree angle are a linear pair. So they're going to add to 180. So if we just basically subtract from 180, we should be good there. So we get 132. So the measure of angle 1 equals 132. In this case, we know that angle 2 and 63 are complementary. It adds up to this 90-degree angle here. So it's basically going to be 90 minus 63, right? And we get 27. So the measure of angle 2 equals 27 degrees. In this case, what we're doing is we're doing a little something different, but we're saying if this is 31, all right, and it's complementary to this angle, and actually, so these are just marked as congruent. So this isn't actually so bad. So in other words, if I find this angle here, then it's the same as this angle here, which is what we're looking for. So all I really have to do is do 90. It's complementary, right? It adds up to this 90. So it's going to be 90 minus 31. And then it's telling me that it's congruent. So in this case, it'll be 59. So the measure of angle 3 equals 59 degrees. I'm doing these math in my head, so I assume I'm doing them right. I've been known to make minor mistakes there, but hopefully I'm not. All right, so we're trying to say always, sometimes, never true in this case. So again, if it's only true sometimes, we say sometimes. If it's always going to be true regardless, it's always. Otherwise, it's never true. So an angle and its complement are congruent. So an angle and its complement have to add to 90. Is there any time that they can be congruent? Yeah, if they're 45. So in other words, there's only one time that they can be congruent, but it's when they're both 45 degrees. Otherwise, that would be the only time. So that would be sometimes. A pair of right angles forms a linear pair. That would be true. A pair of right angles forms a linear pair. Actually, that's only sometimes true. So we know that a pair of right angles will always be supplementary because they're always going to add to 90. But a pair of right angles, right, don't have to necessarily be connected. So if they're not connected, they can't be a linear pair. Even though they're supplementary, they're not a linear pair unless they're adjacent. So we'd say sometimes. So of course, they can be or they cannot be. So if you have one example of each, that's sort of not. And again, if we're looking at the other one, we have sort of an angle and its complement are congruent only when it's 45 and 45. Otherwise, it would be, an angle and its complement don't have to be. So only during this case it is. So if you have one of each examples, then it's going to be sometimes. Okay, so back to 18. An angle and its complement form a right angle. Sort of an angle and its complement form a right angle. That would be sometimes. And again, if I'm going with what they're asking, if I'm interpreting what they're asking correctly, it's basically saying if I have an angle and its complement, well, if I have an angle here, that's 60 degrees, and I have an angle here, that's 30 degrees, right? Well, if I put them together, they form a right angle, but right now they don't, right? Now they don't have to be adjacent. Complementary angles don't have to be adjacent, so we're going to go with sometimes, because they could be together. Again, you could have just, they could be together and form a right angle, a larger right angle, but if they're not connected, then they're not going to be. A linear pair of angles is complementary. Well, that is going to be a big fat never. Linear pairs are going to be always supplementary, and there's no way they can add to 90 if they also have to add to 180. It just doesn't do it there. All right, a couple of more problems here. In this case, we know that these are a linear pair, so we know that 4n plus 5 plus 8n minus 5 equals 180. I'm going to do a part 2. I'm going to do a part 2. Or just finish out the key, because I think they're not so bad. I'll show the work with the rest. See you guys.